Hello guys, welcome once more to class online. My name is Dami, and in this edition we shall be looking at Waec Physics 2013, question number 16 to 20, and we have a lot of fantastic questions that will interest you a lot and teach you a lot in physics in this edition. We have questions on screw jack. Do you know that thing that you used to carry your car when the tire is flat, when you want to lift your car up so that the balancer can walk on the tire or bring down the wheel of the car? You need a screw jack, and that screw jack has a formula for calculating it. Now we'll check an aspect of it in this edition. Remember, this is a past question series, and we won't get to check all aspects of the topic, but just fractions of each aspect as it is asked in the past question. Now don't forget, if you learn something from this series, click on like button. We have a lot to share with you that will better help you understand this. Let's get to number 16. A screw jack has the distance between its successive thread as P and length of a storming bar as R. Its velocity ratio is given by the expression what? Now, there are formulas for calculating the when you are working with screw jack, you need to know the VR. Most of this machine, this is actually a simple machine. Now we also have in the category, we have pulley, we have gear, we have lever, and we have screw jack. We learned all these things under the topic machine. You might want to go over it again. But under screw jack, there's one thing that is very, very important to remember, and that's what this question is asking: the velocity ratio. You need to know the formula for calculating the VR, velocity ratio of a screw jack. And that formula has to do with the diagram. I put a picture here. This is my screw jack placed under my car. You can see that it has a long rod, right? This rod and this rod, okay, and you can see, and that is the pitch, okay. Then we have we also have, it has a length also, length. So the VR of this thing is simply 2 pi L. L is the length, and the pitch is simply the height from this bar upward. As you can see on the drawing, the height from this bar upward is the pitch. So it will become the length of this lever is the second factor. The length is from here to here, while the pitch is from here upward. So the answer for the VR is just 2 pi L over P, where 2 is 2, pi is pi, and L is the length of this hand, of this rod. That's length over the pitch is the height, is the distance from here to here. That is what they call distance between its successive thread, and that's as P, and that's the pitch. Distance from here to here is actually my P, and that is, so the answer is just 2 pi L, 2 pi length over P, and that is the answer for that number 16. Number 17 says heat transfer by conduction is similar to wave motion because what? Now conduction has to do with, is it because there's an increase in temperature, transfer of materials involved, charged particle vibrate at right angle, no transfer of material involved. Now conduction has to do with heat transfer in a solid medium, okay, by the vibration of molecules. Like if you put a rod of metal in fire, it will get hot and burn your hand. Now how did the heat get to your hand? Metal is a conductor of heat. So as the end of the rod touch the fire and burn, it will get hotter and hotter and hotter until it gets hot in your hand. So it is transferring it from the end to your hand, and that's the way a spoon in fire, a metal spoon in fire will start burning your hand. And that's why people, if you are using a spoon that has no insulator in the kitchen, when you are cooking, this spoon will start burning your hand because it transfers it by conduction, and it is a conductor. Okay, now that transfer of it is called conduction because it is by the vibration of molecule. The molecule in that spoon are not moving, but they are sending it by vibration, and that's conduction. Now, how is it similar to wave? It is very similar in this way. Wave motion transfer energy from one point to another, right? Right? Now, there is no permanent displacement of the particle of the medium. That is with little or no associated mass transfer. Wave transfer energy. Also, conduction is also a transfer of energy. But there's another thing, by the vibration of molecules without displacement, right? Now, there is no displacement in wave and in conduction. They only transmit energy without moving. So wave, like if wave is coming from something that is far, that is sending energy to you. but that thing is not living where it is. It is a transfer by the movement of the medium. It transfers energy from one point to the other around a medium, okay? But itself, the mass itself that is sending that energy does not move. So in wave, if I am sending wave energy from my mouth, if I'm sending, oh, it's my mouth moving from here to that end, the sound is moving from me to the end of the room, but this mouth is still on my body, right? My mouth is still on my head. Creating the sound is my mouth. It's not moving, but the wave is moving. So wave is a transfer. Both wave and conduction are similar because they transmit energy, but the mass, the person transferring the energy, is not moving, and that is the answer. So it is by a transfer. It is by a transfer of material. It is because the transfer of material is involved. There's increase in temperature, no. Charged particles vibrate at right angle, no. No transfer of material is involved. I believe they are similar, not because of the transfer of materials involved. I believe the answer to that question is actually supposed to be D. There's a transfer of energy, but there's no transfer of material. That is substance. Okay, energy is not the same with particle. No, particle is not physical. Now. In all wave, there is movement of energy. There's actually wave is a movement of what energy? It is a distortion that transmits energy, right? Energy is being sent. So also in conduction, if energy is being sent from the pulse to your hand that burns your hand, right? Now, but there is no movement of the pulse. So the main stuff, the material is not moving, but energy is moving. So there is no transfer of material. It's supposed to be the correct answer. This is extremely wrong. It is not the transfer of material. Both of them are similar because there's a transfer. There's no transfer of material. Not transfer of material, but there's no transfer of material, and that's the answer. The temperature, it says the temperature at which the water vapor in the air saturates the air and begin to condense is known as what? Is it dew point, critical point, boiling point, or triple point? Now, in the morning when you wake up, you see condensation has happened. That means the water vapor is in the night, but it cools. That means it saturates around the entire place in the night, in the midnight when you are sleeping, and in the morning it starts to condense down into water. So it saturates all the time. While you are sleeping in the midnight, air moves around, but in the morning it gets cold, and then the air starts to condense into water, right? And it begins to come down as dew. So that point where the air is saturated, okay, where the water vapor saturates the air, when water saturates the air and begin to condense, that means the air is full of water. That means there's maximum vapor in the air. That means the air is extremely cold, and then it begins to change back into water. That temperature is called dew point, and that is the answer. So it happens in the morning. You will see dew on leaves. It is because the entire atmosphere in the midnight when you are sleeping and you are snoring, the entire place is cold. Okay, so that means that water has saturated the air. Okay, then in the morning it will get to a point that the water will, because of excess water, and because of the cold, it will start to condense or change it back from air into water, and that's condensation. And that temperature is called the dew point. When air starts changing into water, that temperature after saturation is called dew point, and that's what you see in the morning. So the answer is dew point, and that's the dew you can see on the grasses in the morning, and that happens at dew point. Number 19 says the change of state from solid to liquid occur at what? Is it at constant temperature? When temperature is lower than the boiling point. When temperature, well, it has nothing to do with boiling point because it's from solid like ice block to water. It is not when it boils. Ice block will change to water, not at boiling point. So the water doesn't need to boil. When temperature is just at near freezing point, when temperature is equal to the boiling point, it has this one, D and B are automatically wrong. Ice does not change to water when the ice is boiling. No, it changes to water when you just leave it on the table. When the temperature is hot, it starts changing. Does this happen at constant temperature or when temperature is just near freezing point? Freezing point is backward. It happens at the same, like now, watch this now. this ice now, solid now. When the ice starts cooling, when the temperature starts to rise, that means when you have ice block in your fridge, and you bring it out and it starts cooling, that means the temperature starts rising. It will cool to a point that the ice will start changing. But it melts between 0 degrees Celsius, and that is called latent heat. That heat of melting is called latent heat. Okay, but when it starts melting, the temperature stands still, and when it finally becomes water, the temperature will now start increasing again. Okay, then it will get to a boiling point. At boiling point is the temperature of water stands still again, and that's 100 degrees Celsius. It stands still. Okay, then it will now start changing to gas, to steam that you see on your pot. So at the melting point, the temperature does not rise. It just stands still for the gas, for the solid to change to liquid. So when it is changing, the temperature of that ice block is the same. Is the same. Now it does not increase in temperature. So it will not start going from 1 degree to 2 degree to 3. No, it will stand still to 0 and be changing. Okay, and when it finally changes to water, the temperature will now start increasing, and that is the answer. It happens at constant temperature, at the same temperature. Solid change to liquid or melt at constant temperature. Number 20 says, which of the following type of thermometer can be used to measure a range of temperature from 0 degrees Celsius, from minus 50 degrees Celsius to 50 degrees Celsius. Now this one is very low. Anything negative is extremely cold. Now, what temperature can measure very cold temperature of minus 50? You know, ice block is 0, but minus 50 is more cold than, it is colder than ice block. I mean, it is extremely cold. Okay, now, what thermometer can measure that? Is it clinical or mercury or alcohol? Now, the only answer to that question is actually alcohol. Alcohol has one advantage. Alcohol in glass thermometer has one advantage. It can expand about 6 times of mercury. Expand evenly on heating. It can also a low freezing point. So use a very cold place. So alcohol thermometer is the best thermometer for anything cold. Now it is not common because we are not in the cold region of the world. But if you are in the polar region, you can't use mercury thermometer there because it is extremely cold all around the year. It's cold, so you can only use an alcohol in glass thermometer because it can measure. It has a very low. It can measure extremely low temperature, and it is the only thermometer that can measure a very low temperature as low as minus 50 degrees Celsius, because there is no other temperature that can go that low. Alcohol actually freeze at a temperature range that is lower than minus 50. So it can measure a temperature that is very low as minus 50. So when water is freezing at 0 degrees Celsius, alcohol will not freeze. If you put alcohol in your freezer, alcohol will not freeze. It will not freeze at the temperature that water freezes. It is difficult to freeze pure alcohol. Now you may say that I put drinks in the freezer. It can be cold, but it can't freeze. For you to freeze alcohol, that freezer must work extremely. I don't think I have seen a freezer that can freeze alcohol, because the freezer must get to a temperature of extremely cold to an extremely cold temperature of something close to minus 80 degrees Celsius, because that is the temperature at which alcohol freezes. It is that low. Okay, it needs a temperature range that is extremely low, lower than minus 50, and most freezers stop at minus 3 degrees Celsius. So that's not cold enough. Okay, so for alcohol to freeze, alcohol can measure a freezing point of minus 50, and only alcohol can do that. And the answer to number 20 is just alcohol in glass, and that's the answer to that question. And that brings us to the end of this video. Don't forget that if you learn something from this video and you want more content that will better help you understand things, click on like button. We have a lot to share with you that will better help you understand. Until we see you guys, take care of yourself and bye for now.